Everything you've been told about our dead solar system is a lie. Beneath the silent crust of distant worlds, a restless pulse is waking up. From the sun's ancient trapped light to the diamond rains of the abyss, the universe is screaming. Are you ready to hear it? All of that raw energy doesn't just vanish. It begins a long, tortuous escape. It first moves into the radiative zone. Think of this as a dense cosmic maze. A single photon of light created in the core takes about 170,000 years just to bounce its way through this layer. By the time that light reaches your eyes on Earth, it is already ancient. Beyond the radiative zone lies the convection zone. Here, the energy moves faster, carried by giant bubbles of hot plasma that rise and fall like water in a boiling pot. These bubbles eventually reach the surface, which we call the photosphere. The photosphere is the visible surface of the sun, a layer about 300 miles thick. Even though it's the coolest part of the sun's interior, it still roars at 5,500 degrees Celsius. If you looked closely at this surface, you'd see it's covered in granules, plasma cells that are nearly 600 miles wide, roughly the size of a large state. But the weirdest part? As we move further out into the sun's atmosphere, the corona, the temperature suddenly spikes again to a mind-blowing 2 million degrees Celsius. It's a physical paradox that scientists are still trying to fully grasp. Since we'd be vaporized in a nanosecond here, we'd better keep moving toward the first planet on our list. The first stop on our planetary tour is Mercury. It's the smallest of the four inner planets, but don't let its size fool you. Mercury is an iron cannonball. It is the second densest planet in the solar system, trailing only behind Earth. What makes Mercury so strange is its heart. About 85% of its total volume is taken up by a massive metallic core. Imagine a planet that is almost entirely a giant ball of iron and nickel, covered by only a thin, stony skin. Recent data suggests this core might even have a solid inner center, surrounded by a liquid outer layer, much like our own planet. Because Mercury is so small and sits so close to the sun, it's a world under constant siege. It has almost no atmosphere to speak of. The solar wind, a stream of charged particles from the sun, effectively sandblasts the planet, stripping away any hydrogen or helium it tries to hold onto. Its outer shell is just a 250-mile thick layer of rocky mantle and a solid crust. It's a silent, scorched world of extremes, where you could be freezing in the shadows and melting in the sun at the exact same time. Moving along, we hit Venus, the hottest planet in the solar system. If you brought a block of lead here, it would melt into a puddle in minutes because the average surface temperature is 465 degrees Celsius. But the real nightmare is the pressure. Standing on the surface of Venus feels like being 3,000 feet under the ocean on Earth. The air is so thick it's almost a fluid. Inside, Venus is remarkably similar to Earth in structure, with a core about 2,400 miles wide. However, its mantle is a 1,200-mile thick layer of hot, creeping rock. The crust is a thin, volcanic shell of basalt, but you can't see any of it from space because of the suffocating clouds of sulfuric acid. Venus is a cautionary tale of a greenhouse effect gone completely off the rails. Finally, we return to our home, Earth. We are the densest object in the solar system. Our core makes up 15% of our volume and is divided into two distinct parts. The inner core is a solid ball of iron and nickel, roughly 750 miles in radius. That's about 80% of the size of the moon. Surrounding it is the liquid outer core, a 1,500-mile thick sea of molten metal. The friction and movement here create the magnetic field that protects us from the sun's radiation. Above the core is the mantle, which represents 84% of Earth's total volume. It's made of silicate rocks, rich in iron and magnesium. Our crust is just a tiny sliver, about 1% of the planet, and it's broken into tectonic plates that glide over the mantle as slowly as your fingernails grow. This movement isn't just geological trivia. It's how our planet breathes, releasing internal heat and recycling carbon, making life as we know it possible. It's a delicate, perfectly balanced machine that we are only just beginning to understand. Leaving the comfort of our blue marble behind, we push further into the cold void toward the red planet, the final stop of the rocky inner circle. Mars is often called Earth's sister, but inside, she is more like a fossil. This world is a terrestrial planet, meaning it's built of rock and metal, but its heart has grown quiet. The Martian core, composed of iron, nickel, and a surprising amount of sulfur, stretches about 1,200 miles across. Unlike Earth's churning liquid center, the core of Mars doesn't move much anymore. Because it lacks that internal dynamo, Mars has a pathetic magnetic field, only 0.01% of Earth's. Without that shield, the solar wind has spent billions of years peeling away the Martian atmosphere, leaving behind the frozen desert we see today. The mantle surrounding this core is a 1,000-mile thick layer of silicates and oxygen. If you could touch it, it would feel like thick, cold toothpaste. Above that lies a crust that is strangely thick and entirely rigid. Unlike Earth, Mars doesn't have tectonic plates. Its crust is one solid, unbroken piece. This is actually why Mars has the biggest volcanoes in the solar system, like Olympus Mons. Since the crust doesn't move, a volcanic hotspot stays in one spot for millions of years, piling up lava until it reaches the edge of space. The whole planet is covered in a fine iron oxide dust, literally rusted rock, that gives it that iconic crimson hue. But as we cross the asteroid belt, the rules of physics seem to change. We leave the world of stuff you can stand on and enter the realm of the giants. Jupiter is the undisputed king. It is so massive that if it were just 80 times heavier, it would have ignited into a star. If you were to drop into Jupiter's clouds, you would never find a solid surface to land on. Instead, you would just fall forever through increasingly dense fog. About 90% of this titan is hydrogen, with the rest being helium. But the real secret of the king lies deep beneath the surface. As you descend, the atmospheric pressure becomes so intense, millions of times greater than at sea level on Earth, that the hydrogen gas is crushed into a state that sounds like science fiction: liquid metallic hydrogen. In this layer, hydrogen behaves like a metal, conducting electricity and heat with incredible efficiency. This swirling, metallic ocean is what creates Jupiter's monstrous magnetic field, the largest structure in the solar system. At the very center, there might be a rocky or icy core about 15 times the mass of Earth, but recent data suggests this core might actually be fuzzy, partially melting and dissolving into the rest of the planet's interior. With temperatures at the center reaching 35,000 degrees Celsius, Jupiter is a world of pure, unadulterated power. Next, we arrive at Saturn, the jewel of the solar system. Like Jupiter, Saturn is a gas giant made mostly of hydrogen and helium, but it has a much higher concentration of sulfur, which gives it that distinct hazy butterscotch color. Saturn is the ultimate lightweight. It's so fluffy and low density that if you found a bathtub big enough, the entire planet would float. Inside, Saturn follows a similar blueprint to Jupiter, but with a twist. Deep within its layers, the pressure and temperature reach a point where helium actually condenses into droplets. It literally rains helium toward the core, releasing heat as the droplets fall. This helium rain is why Saturn is much warmer than it should be based on its distance from the Sun. Its core is likely a dense ball of rock and ice, perhaps 10 to 20 times the mass of Earth, wrapped in a thick blanket of metallic hydrogen. And let's not forget the winds. At the equator, the interior heat fuels storms that scream at 100 miles per hour. Leaving the gas giants behind, we enter the territory of the ice giants, starting with the weirdest planet in the family, Uranus. This pale blue-green world is a total oddity because it rotates on its side. Imagine a planet rolling like a bowling ball around the sun. Uranus is 80% ice, but don't think of ice cubes from your freezer. The ice here is a hot, dense fluid made of water, ammonia, and methane. Deep inside, Uranus has a small rocky core, but the bulk of the planet is a vast slushy mantle that scientists call a water-ammonia ocean. Because of the extreme pressure in this mantle, carbon atoms can be squeezed into crystals, leading to the diamond rain theory, the idea that it literally rains diamonds deep inside the planet. The beautiful cyan color comes from methane in the atmosphere, absorbing red light, leaving only the cool, ghostly blue for us to see. Neptune is the true wind king of the solar system. This dark, cobalt blue world is the second of our ice giants and the most distant planet from the Sun. It is a world of pure atmospheric violence. where methane clouds whip around the planet at staggering speeds of 1,200 miles per hour, faster than the speed of sound. Inside, Neptune is a twin to Uranus, but with more inner fire. Its rocky core is slightly larger than Earth's, but the real mystery is the 4,500-mile thick mantle. This is a vast, boiling ocean of hot ice, a super-pressurized mix of water, ammonia, and methane. Deep within this slurry, the physics become truly alien. The pressure is so high that it breaks apart methane molecules, freeing the carbon to crystallize into diamonds. These diamonds then sink through the mantle like sparkling hailstones in a dark, liquid abyss. This process releases gravitational energy, which is why Neptune, despite being further away, is actually warmer than Uranus. As we look back from the edge of the solar system, we realize that we don't just live in a collection of rocks and gas. We live in a massive, interconnected machine. From the fusion furnace of the Sun to the diamond-strewn depths of Neptune, every world tells a story of how matter and energy behave under pressure. We've seen how a planet's heart, its core, determines its destiny. A moving core creates a protective shield for life on Earth. A still core leaves a world like Mars to wither in the solar wind, and an overwhelmed core turns a planet into a crushing giant like Jupiter. This journey reminds us that permanence is an illusion. Every planet we visited is in a state of slow, majestic change. The sun is burning through its fuel, the moon is shrinking, and the gas giants are shifting their internal chemistry. We are part of a dynamic living system that is far more complex than the static dots of light we see in the night sky. The next time you look up at the stars, remember that you aren't just looking at lights, you are looking at siblings. Each one has its own pulse, its own internal struggles, and its own secrets hidden miles beneath the surface. Staying curious about these worlds is how we eventually find our place among them. The most profound lesson from this journey is that environment dictates reality. What is a gas on Earth becomes a liquid metal on Jupiter or a solid crystal on Neptune. In our own lives, we often feel stuck or fixed in who we are, but the cosmos shows us that we are all subject to the pressures and environments around us. Just as hydrogen changes from gas to metal to power a planet, you have the capacity to change your approach when life's pressure increases. Don't fear the pressure. Use it to transform into a more conductive and powerful version of yourself. Every planet that stayed alive did so because of its internal energy. Protect your passions and your inner drive. They are the core that creates the magnetic field protecting your world from burnout. The most valuable resources, like the water on the moon or the diamonds on Neptune, are often hidden in the darkest, most high-pressure places. Don't be afraid to look where others find it too difficult or too dark to go. Thank you for traveling across the system with me. If you've discovered something new about our cosmic home today, give this a like and share the journey with a friend. And as always, stay curious and keep shining with bright side.